हेलो एवरीवन, वेलकम टू केमिस्ट्री एकेडमी। आप सभी को केमिस्ट्री एकेडमी की तरफ से दीपावली की शुभकामनाएं। इस उम्मीद के साथ कि आने वाला समय आपके लिए मंगलमय हो, आपके जीवन से सारा अंधकार इस दीपावली में दूर चला जाए। आइए एक छोटा सा प्रयास हम आने वाली जेईई मेंस परीक्षा के लिए करें। टुडे वी आर गोइंग टू डिस्कस टू क्वेश्चंस ऑफ thermodynamics. These are previous year's JEE mains questions. The first question is, assuming ideal behavior, the magnitude of log K for the following reaction at 298 degrees Celsius is x into 10 to the power minus 1. So here we have to be careful that we have to calculate the magnitude of log equilibrium constant. The value of magnitude of log equilibrium constant should be represented in this form, x into 10 to the power minus 1. So these 2 points are very important for us while solving the question. The value of x we have to calculate up to the nearest integer. The reaction is 3 times of acetylene in gaseous state is giving you benzene in liquid state. Delta G naught formation of acetylene is given as minus 2.04 into 10 to the power 5 joule per mole, and delta G naught formation of benzene is given as minus 1.24 into 10 to the power 5 joule per mole. So we know that when delta G naught formation of reactants and products are given, we can calculate delta G naught of the reaction. Delta G naught of the reaction is equal to summation delta G naught formation of product minus summation delta G naught formation of reactant. And we know how to write the relation between delta G naught and equilibrium constant. Delta G naught is equal to minus 2.303 R into T log equilibrium constant. When temperature is 298 Kelvin and when we are calculating the value in joule, the value of 2.303 into 8.314 into 298 is equal to 5709. This value is given in NCERT, right? So it is assumed that you should save your time in this calculation. Also, 2.303 into R, when the value of R is 8.314, then the value 2.303 into 8.314 is 19.15. This is also given in NCERT, right? Keeping these things in mind, we should know that this value 2.303 into R, when the value of R is given in joule, this is equal to 19.15, and the value of 2.303 into RT, where temperature is 25 degrees Celsius and the value of R is 8.314, this value is equal to 5709. So we are going to use this data to save our time. Let us solve this question. We know that for a chemical reaction, if delta G naught formation of reactant and product is given, we should write that delta G naught of the reaction is equal to summation delta G naught formation of product minus summation delta G naught formation of reactant. So delta G naught formation of product is benzene in liquid state, minus delta G naught formation of reactant with their stoichiometric coefficient. There are 3 molecules of acetylene, so we should write 3 times of delta G naught formation of acetylene C2H2 in gaseous state. Now from the question, if we put the data, the value of delta G naught formation of benzene is given minus 1.24 into 10 to the power 5. I can simplify and write it as minus 124 into 10 to the power 3. Similarly, the value of delta G naught formation of acetylene is given, and that is equal to minus 2.04 into 10 to the power 5. I can write this value as minus 204 into 10 to the power 3. So in place of 10 to the power 5, I have changed the data as 10 to the power 3. Now we can simplify this. If I multiply 3 into 204, this minus and minus will become plus. So 612 minus 124 into 10 to the power 3 will be common. So from here we are getting that this value of delta G naught reaction is equal to 488 into 10 to the power 3 joule per mole. So this is delta G naught of the reaction. And we know that what is the relation between delta G naught of the reaction and equilibrium constant. We should write that delta G naught of the reaction is equal to minus 2.303. R value they have given in joule, we have to use 8.314, and the temperature is 298 Kelvin, right? So the multiplication of this is already known, log equilibrium constant. So from here we can calculate what is the value of log equilibrium constant. The value of log equilibrium constant will be 488 into 10 to the power 3, and we already know that 2.303 into 8.314 into 298, this value is 5709. With minus sign here we can put the value 5709. Now we have to calculate the magnitude of log equilibrium constant. So be careful while solving the question. Log equilibrium constant will be 488 into 1000 divided by 5709. You have to do this calculation, right? So while doing this calculation you have to spend time. So after doing the calculation, what we are getting, this value is 85.47, right? We have to do this calculation up to 2 digit after the decimal place, because we have to write the answer as x into 10 to the power minus 1, and the value of x should be the nearest integer. When I am writing this value, I should write it as 854.7 into 10 to the power minus 1. This is the value of x. When I am calculating the value of x, some of the student will do what? They will write up to 3 digit only, and by that they can get wrong answer. After investing a lot of time and you know the question, then also you are not able to get the answer. So be careful when they are asking nearest integer. You should solve this up to 4 digit, right? And now if you round off from here, you are getting that the answer is 855 into 10 to the power minus 1. So the value of x is equal to 855, right? तो क्या ध्यान देना है हमें? क्वेश्चन आसान होता है, राइट? तो आपको क्वेश्चन को ध्यान से पढ़ना है, ये दिमाग में रखना है कि हमें आंसर किस फॉर्म में रिप्रेजेंट करना है. ओके, so let us move to the next question. The answer for the first question is 855. The second question is, the reaction of cyanamide NH2CN with oxygen was run in a bomb calorimeter. You know that bomb calorimeter का मतलब होता है the reaction is carried out in a container where volume is constant, and delta U was found to be minus 742.24 kilojoule per mole. The magnitude of delta H at 298 Kelvin for the reaction is given NH2CN in solid state plus 3/2 times of O2 in gaseous state will form 1 mole of nitrogen gas, 1 mole of CO2 gas, and H2O in liquid state. We have to calculate delta H for this reaction. We have to write the answer up to the nearest integer, and we have to assume that the gas is ideal gas. This is an important point, and the value of R we have to use is 8.314. In order to solve this question, we are going to use this relation H is equal to U plus PV. When we are using this relation between internal energy and enthalpy, we know that for any system, we can write that delta H is equal to delta U plus P2 V2 minus P1 V1. In case of a chemical reaction where the reactant and product are gases, some of the reactant and some of the product are gases and they are ideal gas, we can use ideal gas equation. So P2 V2 is equal to N2 into RT, because the reaction is taking place at a constant temperature of 298 Kelvin here, right? So P2 V2 is N2 into RT, where N2 is the number of moles of gaseous product, and P1 V1 is equal to N1 into RT, where N1 is the number of moles of gaseous reactant. So if I simplify, now I can write that delta H is equal to delta U प्लस डेल्टा एन जी आर टी। तो ये भी हमें ध्यान रखना है, कई बार जेई मेंस और एडवांस में क्वेश्चन पूछे गए हैं जहां पे ये कहा गया है कि जो गैसेस हैं वो आइडियल से डेविएट हो रही हैं, देन वी कैन नॉट राइट डेल्टा एन जी आर टी। डेल्टा एन जी आर टी कैन बी यूज्ड व्हेन द गैसेस आर बिहेविंग ideally. Sometime they will not mention that the gases is behaving ideally or the gases is behaving as real gas. Then from the data, if only the temperature is mentioned, nothing is mentioned about pressure and volume, then it is an indication that we can solve the problem only when we assume the gases as ideal gas, right? So depending upon the data and the instruction given in the question, we can solve it. Be careful here. We have to calculate delta H in kilojoule, and the value of delta U is also given in kilojoule. When we are putting the value of R as 8.314, this whole thing is coming in joules, so we have to convert this into kilojoule. We should divide it by 1000. तो अभी अगर हम वैल्यू पुट करते हैं, we should calculate what is delta Ng of the reaction. So if you see back in the question, डेल्टा एन जी ऑफ द रिएक्शन इज राइट हैंड साइड में नाइट्रोजन का 1 मोल, CO2 का 1 मोल. सो ऑन द राइट हैंड साइड द नंबर ऑफ मोल्स ऑफ गैसेस इज 2 मोल. On the left hand side the number of moles of gases is 1.5. So 2 minus 1.5 is half. So we can write here that delta Ng is equal to half. Delta H is equal to delta U. Delta U minus 742.24 plus delta Ng. Delta Ng is half. The value of R we have to use. The value of R is 8.314 and the temperature is 298 Kelvin. If I divide this value by 1000 and simplify it, this will cancel out. This is 149. So we should multiply 149 by 8.314. So in exam the student have to do this calculation. You should not hesitate while giving time to this calculation, right? So don't take approximation and solve it, because you have to write answer up to the nearest integer, right? You cannot take approximation. This is a very simple calculation. If you give time, you will find out the calculation. So if I calculate the value of 8.314 multiplied by 149 divided by 1000, I'm getting this value as 1.238. If I have to write up to 2 decimal place, I should write it as 1.24. From here, if I write that what is the value of delta H, the value of delta H is equal to minus 742.24 plus 1.24. On simplification, we are getting that the value of delta H is equal to minus 741 kilojoule. Again, after solving the question, we should read the instruction that we have to calculate the magnitude of delta H. Okay, so magnitude of delta H for this is 741. So 741 kilojoule will be the answer for this question, right? Very simple thing you have to keep in mind while solving the question in exam. Read the instruction carefully, right? किस यूनिट में हमें आंसर देना है इसका हमें ध्यान रखना चाहिए. कई बार क्वेश्चन आप सॉल्व करते हैं, इस बात का ध्यान नहीं रखते हैं कि क्वेश्चन में मैग्नीट्यूड पूछा गया है. तो इन दोनों क्वेश्चंस में आप देखो तो मैग्नीट्यूड ऑफ लॉग इक्विलिब्रियम कांस्टेंट एंड मैग्नीट्यूड ऑफ डेल्टा एच दे हैव आस्क. यदि आप हमारे चैनल पे नए हैं, हमारे चैनल को अगर आपने सब्सक्राइब ना ही किया है तो प्लीज़ इसको सब्सक्राइब करिए और वीडियो को लाइक करिए. अगर आपको इस तरह का और मटेरियल चाहिए और इस तरह के डिस्कशन चाहिए तो हमारे चैनल में अगर आप अबाउट में जाएंगे तो ऐप की लिंक है. आप ऐप की लिंक को डाउनलोड करके केमिस्ट्री से रिलेटेड बहुत सारे कोर्सेज यूज़ कर सकते हैं. लाइक देयर आर कोर्सेज related to the full syllabus of JEE Advanced. There are courses for class 11th JEE Advanced. There is a crash course for JEE Advanced, and there is courses which is available topic wise. So depending upon your requirement, you can choose among these, and they are very helpful to you. If you have left some topic and you are not confident that I'm not able to solve the questions of this particular topic, you can take our course, you can download our course, you can subscribe our course, and it is going to be very helpful to you. हमने टॉपिक वाइज में शीट, डीपीपी और बहुत सारे एग्जाम्पल्स को डिस्कस किया है विद अ डेप्थ थ्योरी डिस्कशन. So hope this is going to be very useful to you. Thank you very much. Bye bye.